Okay, this video, this is the second video regarding the exponential function. This it says part 2. Previously we have seen the exponential functions regarding with rational exponents. So let me see the examples one by one. Okay, before we are going to explain something about irrational exponents, first we have to define what is irrational number means or irrational numbers means. Previously you have learned about rational and irrational numbers coming together gives real numbers. So sometimes or some numbers having decimal form of neither repeating nor terminating are said to be irrational numbers, like for example 0.424424442. In this way the numbers are not repeating, but it's never terminated. This way this kind of numbers are said to be irrational numbers, or in other words the numbers under radical of the numbers non-perfect square numbers, like radical 2, like radical 3, like cube root of 4. Just like these numbers are the best example for what? Irrational numbers. So those are the numbers. So in this video we will see a number a the power of x, where x is an element of what? Irrational number or irrational numbers. Okay, irrational numbers. So this means we will see one by one. Okay, let me proceed. The first example that we are going to see is 6 the power of radical 5 is an example of a number or power form or exponential function or exponents with irrational exponents, irrational number, because radical 5 is irrational number. Because the reason why we say it was radical 5 is irrational number, there is no any rational number which gives the square of the number what? How much? 5. So it is impossible to take out the number 5 from radical in easy way or in irrational number form. So this answer to you as irrational number. Okay, let me see the practical example. Previously again we have seen in previous video you have seen the laws of exponents. By using that laws, let me see the different examples. For example, let's say the first one. This is, let's say, a. Simplify the following. This means, as we know that a the power of x times a the power of y can be simplified as a the same base but different exponents. We can add only the exponents a the power of x plus y type. So from this, for the power of radical 3 times 4 the power of radical 12. Yes, radical 12. So this becomes 4 the power of radical 3 plus radical 12. This is equivalent to 4 the power of radical 3 plus radical 12 can be simplified as twice of radical 3, because radical 12 is equivalent to radical 4 times 3. 4 can be taken from the radical, that is 2, so twice of radical 3. So radical 12 can be equivalent to twice of radical 3. So finally this is the coefficient for the radical 3 is 1 and for the second one is 2, so it can be added simply for the power of 3 root 3 for the power of 3 times root 3, or simply just for the power of 3 is 64 the power of 3, the power of radical 3. For the second example, we have for the numerator part we have the same base, but the denominator part the base is 8, but it can be changed into the number base, then base 2, so it's to the power of radical 5. Yes, radical 5 plus, this means radical 20 over 8 can be simplified as to the power of 3 the power of radical 5. This radical 5 is this one, and 3 is this exponent is the base example or the exponential statement of the number 8. So from this, to the power of radical 5 s plus 20 can be written as 4 times 5. The reason that we choose the number 4 times 5, 4 is a perfect square number, but the number 5 is not. So it can be written as twice of radical 5, right? Radical 5 over to the power of 3 root 5. In this context, we know that a the power of m, the whole power of n can be written as a the power of m times n. We can multiply the exponents in this case. So from this, that's why 3 times radical 5 is 3 times radical 5 in this context. So this means to the power of 3 root 5. Okay, it becomes what? 3 the power of 1 to the power of 3 root 5 over to the power of 3 root 5. We can simplify this way, these numbers in two ways. The first one is they are the same, the number divided by itself is 1, or just simply cancelled, it becomes what? 1. Or by using what exponential laws, we can write to the power of 3 radical 5 minus 3 radical 5. We can put just like this because the same base. Again, we know the rule, a the power of m over a the power of n can be written as a the power of m minus n, because the same base but different exponents. If we multiply the number a m times, and if we multiply the denominator part a times a n times, so just simply m minus n should be the left quotient. So from this 3 minus this becomes what? This is equivalent to the power of 0. To the power of 0. Again, we know the rule, a the power of 0 is equal to 1 if a is different from 0, right? So in a number, this number base is other than 0 or completely different from 0, to the power of 0 is equivalent to just 1. It becomes what? 1. Okay, let's see the other example. The third example regarding with irrational exponents, just to simplify. Since from the first, the numerator part, the first two numbers have the same basis, but the third one is different from the first two bases. But again, it can be simplified, or it can be expressed as base 3. The denominator also base is 3, so it becomes 3 the power of radical 2 minus, because this is minus negative, right? It's negative, so it's minus radical 2, which means radical 2 plus the negative radical 2. So finally it becomes 1 times 27 can be simplified as 3 squared to the power of 3 the whole the power of radical 2 divided by, again, radical 8 can be simplified as, it can be written as radical 4 times 2. This means 3 is the power of twice of radical 2. So from this, it can be written as this is equivalent to, this becomes 0, right? Because equal and opposite. 3 is the power of 0 plus 3 times root 2, because this 3 times radical 2 can be multiplied, divided by 3 is the power of 2 root 2. This means 3 is the power of 3 root 2 over 3 is the power of 2 root 2. This means just we can bring it, this one then make it minus 3 root 2 minus 2 root 2. So this is equivalent to 3 to the power of 3 minus 2 is 1, so it becomes 3 to the power of root 2. Finally, we can put just like this, so the final answer. So radical 2 minus radical 2 is 0, and this becomes what? 3 to the power of 3, because 27 can be written as 3 to the power of 3 divided the power of radical 2, 3 times radical 2. The lower part becomes what? Twice of radical 2. So finally it becomes 3 to the power of radical 2. Okay, for this, the fourth example, let's say this means it can be multiplied to the power of twice of radical 3. We can make it this division into over, for to the power of twice of root 3 times the whole power, this is minus 2. So this is times. Okay, this is a product, so it becomes 1 to the power of 2 root 3 over, this can be written as to the power of 4 root 3. This is negative because negative times 2 is negative, so it becomes what, to the power of 2 root 3 minus of 4 root 3. Minus times minus is plus, so it becomes to the power of 2 twice of root 3, yes, root 3 plus 4 radical 3. So this can be written as to the power of 6 times radical 3. It becomes what, to the power of 6 times radical 3, or just it can be simplified easily. To the power of 6 is 64, yes, 64, the power of radical 3. It becomes 64 the power of radical 3. The same, those two are the same. Okay, the similar statements expressing in different this is a statement. This statement can be written as the base is over here 3, but this one is 9, so we can change it to a similar bases. So the first becomes 3 the power of 2 times radical 2 is twice of radical 2, yes, radical 2 times 3 the power of 2 the whole the power of negative root 3, yes, root 3 divided by 3 square means the number 9, and negative root 3 itself and the number itself. So 3 the power of negative radical 3 can be again written as twice of radical 3, because 2 can be taken inside the radical and it can be changed to 4 times 3 is 12. So from this this is equivalent to 3 the power of 2 radical 2 times 3 the power of twice of the negative of twice of radical 3 divided by 3 the power of minus twice of radical 3. Now these two numbers are equal, yes, equal with the same base with the same exponent, so it can be simplified into one times. So finally it becomes 3 the power of twice of radical 3. It can be simplified just like this, 3 the power of 2 times radical 3, or just 9, 3 square means 9 the power of root 3, 9 the power of radical 3. Okay, for this example, this one radical say we know the rule radical a times radical b can be simplified as a square root of a times b, putting together with b if they have the same index. So from this our index is 2 in both contexts, in both cases, so we can mix it inside, okay, inside, which means 5 is 5 minus twice of root 6, just we have to put inside the bracket because these two numbers are binomial numbers. So 5 plus twice of root 6, we know that a plus b, yes, times a minus b type, meaning the product of two binomials with different sign inside the numbers. So it can be equivalent to a square minus b square. So from this the same value, the same numbers, but the only signs are opposite on this one, divided by this can be the number taken from the cube root, so it comes negative 5, because negative 5 the power of 3 it gives negative 125. This means 5 times 5 is under radical 25, yes, 25, this minus this type, okay, just like this that type. 2 times radical 6, the square means 2 square is 4, let's write it over here, 4 times radical 6 times radical 6 is 6 itself, divided by negative 5, so it is equivalent to 25. This means radical 25 minus 24, yes, radical 25 over minus 24 divided by negative 5, which is equivalent to 25 minus 24 is 1 from the radical taken from the radical is 1, so 1 over negative 5, which is equivalent to the negative of 1 over 5. 1 over 5. So our final answer is negative of 1 over 5. So the simplified form of this expression is equivalent to negative 1 over 5. 1 over 5. This is the way that's why we're going to solve. Okay, let me give you some important notations regarding with exponents. If let a greater than b greater than 1, which means all are positive or greater than 1, let's say a is 3 and b is 2. For the first statement, let's say this is Roman number 1. The first is a the power of x greater than b the power of x for x greater than 0. Is it true or false? So our answer is yes. Let me see it by practical example. For this one, x is greater positive. Let me say x is 1 simply. It's in simple way. So this statement can be written as 3 to the power of 1 is greater than to the power of 1, which is true, right? True because 3 greater than 2. 3 is greater than 2, so it is true. That's why you say what? Yes, that's the reason. For the second statement, if x is below 0 or negative number beyond, if it becomes negative number, so what will happen? If is it always true? 3 to the power of minus 1 is greater than 2 to the power of this should be 2 to the power of minus 1. Is it true? This means since this the exponent is negative, it can be written as 1 over 3 is greater than 1 over 2. It is a false. Okay, it is false because 1 over 3 is smaller than 1 over 2. When you crisscross it, this means 2 is greater than says 3 is false. So this statement is says what? It's no. For the second one, this is first the first one. This is, let me say, the second. For the second one, what will happen if a is less than b or n and b are between 0 and 1? Let me say a is equivalent to 1 over 3 because it is smaller than b, and b is again, let me say, 1 over 2 in easy way, in easy practical example. Don't forget in mathematical statement, if it's one thing fails, if for a single number fails, it is not generally, it's not acceptable. So from this, let us say if x is greater than 0 or just x is positive, what will happen if x is positive? This means, let us say x is again 1 for this one, and for this thing x less than 1 is, let's say x is negative 1. So from this, if a the power of x is greater less than b the power of x, is it always true for positive number x? So this means, let us say 1 over 3 the power of 1 is less than 1 over 2 the power of 1, because we are taking the number x for x is 1. This is 1 over 3 is less than 1 over 2, and it is true. It is true. Why? Because 1 over 3, when you crisscross it, 3 times 1, and this becomes what? 2. 2 is less than 3, and it is true. For the second statement, what will happen if x is negative or the exponent is negative, which means 1 over 3, yes, power of negative 1 is less than, according to this statement, okay, less than 1 over 2 the power of minus 1. This means the reciprocal of this one, which is 3 is less than, says 2, because 1 over 2 the power of negative 1 is equivalent to 2. So it is false. Okay, it is false. It is false statement. So our answer is no, it's not possible. But if the sign is greater than, it will be true. For this one is, it is always becomes true. Okay, thank you very much for viewing my videos. Please subscribe and share for your friends for better information, specifically from this channel will present for grade 7 to grade 12 in different subjects like English, mathematics, chemistry, physics, all selected subjects from grade 7 to grade 12. Specifically for high school levels, we will see me present different subjects. In the next video, we'll see the logarithmic statement. Thank you very much.